welcome to my tutorial on QUIC. This is task 6.3H of SIT202. My name is Ayan Umar Siddiqui. My student ID is S224777251. And today I'll explain what QUIC is and why it matters and how it changes the way we use the internet. So we'll explore its functions, benefits, challenges, and I'll even show you a live demo in Wireshark. So let's just proceed. So basically, what is QUIC? QUIC stands for Quick UDP Internet Connections. It was first introduced by Google and is now standardized by the IETF. Unlike TCP, QUIC runs over UDP, but adds all the features we normally expect from TCP, such as reliability, congestion control, and flow management. What makes QUIC different is that it combines these transport features with built-in encryption, making it secure by default. Yeah. And why do we need QUIC? So basically, we have traditional like TCP requires a three-way handshake before any data can be sent. When you add TLS for security, that means another handshake, which increases latency. With HTTP /2 over TCP, there's also the issue of head of line blocking. So if one packet is delayed, everything else waits. So that's why QUIC solves these problems. It combines the transport and TLS handshake into one. So there are connections can start almost instantly, sometimes with zero round trip time. It also multiplexes multiple streams, so one lost packet doesn't freeze the other packets. So yeah. And QUIC packet and frames. So inside each QUIC packet, we have frames. Stream frames carry like application data. ACK frames acknowledge receive packets, and crypto frames carry TLS handshake messages. So, and max underscore data frames manage flow control. The really powerful part is multiplexing. QUIC can send multiple independent streams in one connection. So if one stream experiences a delay, the others continue unaffected. So yeah. So then now the advantages of QUIC. So QUIC brings several advantages. First, faster handshakes. You don't waste time waiting to set up a connection. Second, multiplexing prevents head of line blocking, which basically improves performance for modern web pages. Third, security is built in every QUIC connection. So that basically uses the TLS 1.3. And the last and finally, the QUIC is especially good for lossy or mobile networks since it can recover from packet loss without stalling everything. On the other hand, we have disadvantages of this as well. So the disadvantages of QUIC are every packet is encrypted. Okay, QUIC isn't perfect, so every packet is encrypted. It requires more CPU power, which can be a challenge for smaller devices. Debugging QUIC traffic is also harder since you can't just read the packets like plain TCP. And finally, because QUIC uses UDP and everything looks like encrypted data, some firewalls and mailboxes may struggle to handle it properly. So yeah, those were the disadvantages of QUIC. Moving on, we have applications using QUIC. So applications like Google, Facebook, Cloudflare, Zoom, WhatsApp, and the HTTP/3 built on QUIC use basically the QUIC. So despite these challenges, QUIC is already widely deployed. like services like these, like displayed over here, and like everyone has adopted basically for many websites. Applications like Zoom and WhatsApp also benefit from its low latency, and HTTP3, the latest version of the web protocol, is also like built in on QUIC. So when we're browsing mountain websites, we might already be using QUIC without even realizing it, that we're actually using the newest version of the web browser. So yeah, that was the applications using QUIC part. Basically, there are threats and security to this as well. So security is central to the QUIC part, since encryption is mandatory. Many common attacks are prevented, however, new threats exist. So that's why amplification attacks are possible, but QUIC uses validation tokens to limit them. Replay attacks are prevented by using unique packet numbers that can be reused, and of course, man-in-the-middle attacks are prevented by TLS 1.3. So overall, QUIC is considered more secure than traditional TCP plus TLS. So yeah, those were the security threats of basically the QUIC. Now we will be moving forward to scalability. So scalability. Um, QUIC scales well for today's internet traffic. It works perfectly with the global content delivery networks, helping them to reduce latency. It's especially effective for mobile and streaming devices, streaming services, sorry, for like video calls or YouTube. But scalability also depends on infrastructure, like servers, browsers, devices. They all must, support QIC. And adoption is also growing quickly, but not every system supports it yet. So that's just the basic like scalability part of this. Um, so now I'll be basically showing you the demo of Wireshark. So we will be proceeding towards that. So I will be going to the Wireshark demo now. We'll be just filtering it out with QIC. There we have it. And then we'll be stopping our Wireshark. So as you see, we have a lot of QIC protocols over here. So we'll just go on top. We have the so let's see, like we're seeing like basically QIC in action. So here in Wireshark, what I've done is that I've filtered it out with QIC. Um, there's this initial packet over here. It carries the client hello, which is part of TLS 1.3. There's also server hello in response to it. So, after that, packets contain encrypted application data inside stream frames compared to TCP. There's no separate handshake and TLS like TCP. So basically, it's all like, so in QUIC, it's all combined in one step. This shows basically how QUIC speeds up things and while keeping everything secure. So yeah, that was the demonstration of Wireshark. That was the demonstration of QIC and Wireshark. Now we'll be having this comparison between TCP and TLS and our QUIC. So basically, to summarize this comparison, so what happens is that we have handshake of TCP plus TLS 2 steps and QUIC 1 step. So TCP plus TLS requires multiple steps for setup, while QUIC combines it into one. Um, Whereas in multiplexing, no, there's no blocking of head of line blocking over there in TCP and plus TLS, but there is have line blocking and QIC. While and in the encryption part, there is TCP and T plus TLS. It's optional, but it's mandatory in QIC. So it's basically TCP relies on optional TLS for encryption, whereas QIC mandates TLS 1.3 for every connection. So yeah, that was the comparison between the two. Now we will be moving on to our final part of this presentation. It will be the conclusion. So basically, we have over here is what to basically conclude. QIC is faster. It's like more secure and better suited for modern internet needs. It's the foundation of HTTP/3, which means it will soon power most of the web. While it has challenges like CPU usage and middle box compatibility, um, the benefits clearly like outweigh the downsides. So yeah, that was my whole presentation, whole video tutorial on QUIC. So thank you for watching this tutorial on QUIC. I hope I gave you both like the insight and the practical understanding of this protocol. So yeah, thank you.